Assalamualaikum warahmatullahi wabarakatuh. Today we want to present wind energy as a wave energy harvesting avenue. So yeah, from Group 4 to from Electrical Machine Section 1. Today we want to present about renewable energy. So our group choose wind energy as our topic, and we are going to present today. We have four members, and my name is Naufal Awad bin Nordin Asimi, EC 19006, and I have three more friends, so they can introduce yourself.
My name is Muhammad Alif Mughib Samsubari, EC 19020, and my other friends.
And my name is Muhammad Azharan bin Ahmad, EC 19007, and my partner.
My name is Tuan Muhammad Radi, Tuan Muhammad Afandi, EC 19003.
Okay, so we can move to the next slide.
Okay, for the first part of this presentation, I would like to talk about an overview, meaning the general perspective of wind energy. Um, in this current century, mankind are searching new ways to produce or generate electricity without using any fossil fuels. So the best alternative, in our opinion, is wind energy. Wind energy is the combination from the energy from the sun coming to the atmosphere. From the atmosphere, the energy from the sun cause the wind to have kinetic energy, and that from that kinetic energy we can use to rotate the windmill to produce electricity. As you can see, most modern countries like United States of America, India states like Texas and California, they are beginning, meaning that they are in the middle stage of using wind energy on mass. Wind energy is better for our future and for the environment because it is very clean and it is environmentally safe. Uh, Nevertheless, not all countries in the world follow the same trend. Next slide. Okay. Uh, Early in human history, we already have wind power or wind energy, but mostly it is used for agriculture, for milling flour. But now we can use wind energy to produce electricity. As you can see, right now the forefront of the technology for wind power is China, United States, Germany, Spain, and Italy. For Malaysia, we mostly use solar, hydroelectric, and coal. But the potential is there for Malaysia to apply wind energy, especially on windy areas like at onshore or at sea. That's right. The concept or the principle of wind energy is simple. We use the kinetic energy from moving wind to rotate the windmill. The windmill rotates its shaft, and from the rotation of its shaft cause the electromagnetic uh, to produce electricity. From that electricity generated, we can use it to store or to distribute to any region for commercial or residential or industrial purposes. Right now, the most popular types are horizontal axis and vertical axis. That's like in horizontal axis meaning that the axis of rotation or the shaft of the that windmill, it is parallel to the ground. Horizontal axis or HAWT are mostly commonly used and they are usually have a propeller with three or four blades. Why? For VAWT or vertical axis wind turbine, it is different where the axis of rotation is perpendicular to the ground. It is unique because of its design, it can harness any direction of wind instead of horizontal. Horizontal needs its winds to blow to its direction opposite to it so that it can rotate or generate electricity. Next. Here is the common design for horizontal axis wind turbine. As you can see, it has to be constructed high for at least 100 meter, maybe 150 meter to harness the strong blowing winds in the atmosphere. As you can see, the design is always accompanied with three-bladed propeller. Because of its construction, it can use or harness strong winds. Next. The next type is vertical axis wind turbines. As you can see, the axis of rotation and the design of the leg is very unique because uh, it can be moved by any wind by any direction. Sometimes it is called an egg beater design. Next, the because of its design, the gearbox and any electrical components can be located at the base, meaning that instead of being constructed hundreds of meters high, technician can service and maintain its necessary component on ground level. Because of its design, we does not require any complicated design like wind sensing or orientation for its blades to follow the wind direction. Next. As I said before, for vertical, it does not need to be adjusted to direction. It's ideal for winds with for region with no definite or consistent direction of wind. While for horizontal, if you want to maximize the production or the generation of electricity, you should use a horizontal one. Next. And I pass it for my friend who can introduce us about the case study for wind technology.
Okay, Assalamualaikum. Uh, we 2.0 case study wind energy technology, current and future research and development in United States of America. For year 2020, United States of America have installed more than 107,443 megawatt of wind energy in 2020, and more are expected to be installed to meet the demand. Wind turbines have advanced quickly in the course of recent years, and the turbine have developed uh, in size from 100 kilowatt in the mid of 1980s and to over 2.5 megawatt today for per one wind turbine. The advancement of wind innovation is required to reduce the cost and catch more wind energy efficiently. This advancement can empower the energy sector with green energy and reduce emission as the world is currently having global warming. The United States is projected to generate 20% of the total electricity through wind energy 2030. There are a total of 60,000 of wind turbines that have been installed across United States of America as of 2020 that can generate 14.3 gigawatts as in figure 2 below. Besides, In 2020, the wind energy accumulate only at 7.3% from total of electricity sector. This can be proven in the figure 1. Next slide. Okay, in the figure 1, we can see the United States utility scale electricity generation by source, amount and share of total in 2019. For the by the end of 2019 and by the start of first quarter of 2020. Uh, from the utility scale, we can see that the wind power only amass of 7.3% uh, of the total electricity, and this will will become more uh, towards 2030, so that the USA can achieve 30% of electricity total of wind energy to produce electricity by 2030. And for the figure 2, we can see that on the charts of the US wind capacity by initial operation by year from 2010 to 2020, and uh, from the dark blue, it is an operating power, and the bright blue is a planned generated power that are planned to generate. For 2020, they plan to generate more than 14.3 gigawatts, and there are more wind turbines that will be installed to projected the plan. Next, future wind energy research and development in United States. There are many private companies and government of United States have cooperate through research and development. Usually, the government through uh, 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 through AWA, which is United States Wind Energy Association, to research to make the wind turbine more efficient to generate more power. For example, through these years, they have been researching for ways to make wind turbine more robust and make them need less maintenance. For example, on the offshore wind turbines plant, as the offshore wind turbine plant will be placed above seawater, so it is prone to corrosion. So it must be designed to be more robust. It also must be less in maintenance, as the cost will become more higher due to transportation of maintenance crew from land to the offshore plants. By this time, more than 58% of US offshore wind plants are located in deep water areas. So the structure must be fixed to the seabed. So the structure that fixed to the seabed are not practical. To compensate with this situation, US company have developed and researched more in an innovative way. For example, they can float the offshore wind platforms using a uh, spar buoy tension leg platform or semi-submersible platform. As we can see the example in the figure uh, up next. And besides, offshore platforms have more than 5 types. For example, one of the example is monopile, which is usually located at the shore, near the shore of the seawater, and uh, to less deep depth bottom sea bottom, there are 3 types: monopile for like jacket, tension leg platform, and for more than above 60 meters depth, there are 2 kinds. For example, spar buoy and semi submersible. uh, And besides, there are the next there are next generation wind technology that are currently being innovated and being researched truly with the help of Wind Technology Energy Office (WITO). Uh, they have helped facilitate this to be next generation of wind technology through development of longer, lighter rotor blades, taller tower, more reliable drivetrains, and performance optimizing control system. And we too have worked with other industry partners to develop an innovative wind turbine blade to wind turbine blade that has led to energy increase to capture the wind of energy by more than 12% than other than the conventional blade. The blade is called Sweep Twist Adaptive Rotor Star. Sweep Twist Adaptive Rotor, which is star blade. And the blade is uh, shaped at curve at the tip to take the maximum advantage of the wind speed at higher speed or slower speed. And we can see at this figure at the figure of this example. Next. Okay. Uh, to implement the system in Malaysia, we know that Malaysia is not well known for producing electricity by wind harvesting because majority of town in Malaysia only gets an average about 1.8 milli per second meter per second 1.8 meter per second of wind speed, and the wind speed does not blow uniformly. Malaysia demand in electricity by 2020 is expected to reach around 124,677 gigawatts per hour. So if wind power is made say 10% of this projected electricity use, the total land area of Malaysia needed for windmill is around 18,977 square kilometer. This area is equivalent to 6% of total land area of Malaysia, or equivalent to over 1.2 million windmills to be set up. Currently, it costs about only RM 1 for every 1 watt of electricity generated from wind energy in Malaysia. So to meet the 10% of Malaysia electricity demand in 2020 would cost approximately RM 1.4 billion to set up. Okay. To implement the system in Malaysia, we can copy the system in United States, which is an offshore wind turbine plants. We know that Malaysia have a big coast surrounding its territory, so the most other way by using offshore wind turbine system. The most other way is by using offshore wind turbine system. Although the costs are much higher than landed one, it is more efficient to produce electricity as the wind blow constantly in the coastal area. Besides, there will be less maintenance as it is more robust. And for starters, this maintenance can be implemented on an islands of Malaysia to generate electricity to island. Uh, this can be implemented in coastal areas, especially in East Peninsular Malaysia and East Malaysia, including small islands such as Perhentian Island. The island could benefit from wind energy more rather than having to put underground uh, underwater cable that will be really that will be hard to put. Beside, the other one is also using landed wind turbine plant at high wind speed places. Uh, during this this type of landed wind turbine, I have searched that there are some research that have been done that gave an great average of wind speed. such as in East Coast of Peninsula Malaysia, Kota Baru, Kuala Terengganu, and Mesing, that have exceeded average of 3 meter per second of wind speed. Also in Kuching, in Sabah, also in Sabah. The most suitable waste implementation system is by choosing the best places with high wind speed, such as in East Coast Peninsula, and with higher tower to compensate the low speed of the wind blowing. Beside, Tenaga Nasional Berhad reported that there are such as the Malaysian-Thailand border, which see wind speed up to 50 millisecond, and the windmill at the use of wind turbine at these places will be more suitable and have potential. It can generate electricity for home as the places in the near future if implemented. Also, using the newest technology such as Starblade, it can improve more the efficiency of the wind turbine, and to catch more wind blow. Uh, Although that it is more expensive, it is more uh, for long investment. Next. Okay, from market analysis, we can see that I have to before that Malaysia demands electricity will be expected to be 2020 is expected to reach 124.677 gigawatt per hour. So by doing the calculation that have been researched, that have found uh, the total mass of the area to accommodate uh, 6% of total to accommodate the windmill is at 6% of the total land area of Malaysia, or equivalent to 1.2 million windmills to be set up. So it will be cost around 1.4 billion to set up the required number of windmills. This figure show that it is possible to harness the wind energy for electricity generation in Malaysia. Thank you. I give the presentation to my friends.
Okay. Next.
Back slide, back, please. Previous slide.
Previous slide or next slide?
Previous.
This slide.
After market analysis.
Yes, this slide.
Okay. Uh, for the, as all we know, any technology can be improved if we have the initiative or the idea to improve it. For for my part, we can improve it by first improve the material of the construction. We know that one of the best place to construct a windmill is at the sea. So the material used for construction must be improved. Next, we must improve it to design for construction at the sea for offshore wind turbine, because we know that the the most productive region for wind turbine construction is at the offshore. Next slide, please. Okay, for the first point, for previous slide, please. For the first point, wind turbine material. Okay, commonly we use as materials like high modulus fibers like glass carbon fiber, so that they can be sturdy and resilient. But the problem is at sea, the content of salt is very high, really high, such that if you construct it with normal alloy or metal, it will cause rust, especially if the material has high content of iron. So the main threat to wind turbine at sea is salt content. So we must select a material that is very resistant to salt and rusting. And the next point is to be on the safe side, because we construct our structure at sea, we must use materials that are environmentally safe or environmentally green, like from wood, bamboo, cocoa flax, things that are very safe for the environment, especially for flora and fauna, for sea life. Even the resin to construct the bearing or the connection or the joint of the wind turbine must be used from environmentally safe substance. This the focus of us using environmentally safe material is so that the carbon footprint can be reduced, meaning that we want to reduce the carbon footprint from before the wind be constructed, meaning the material we use like wood or metal, it from the beginning does not destroy the environment. In short, next slide, please. Okay, the placement of wind turbine. Normally, we can get 2 to 5 megawatt, but for further the construction of wind turbine from the land, the higher it can get, and we can construct high enough wind turbine from 80 meter to 150 meter, and because of offshore, we can use more complex design. In addition, we when we construct wind turbine offshore, the design can be larger than usually we construct near residential or industrial areas. Next slide. Next slide, please. As you can see, these are the design and the distribution of wind power electricity. As you can see, from the energy generation from the sea, it goes to the substation and finally reaches land. After that, from the electrical pylon, it reaches the residential, commercial, industrial region. As you can see, it is better because there are no production of greenhouse gases or any increase of temperature due to combustion. Okay, for the next point, I give to my friend.
Okay. My name is Tuan Muhammad Radi. So my point is government policy, research, grant initiative, and etc. to implement harvesting energy, wind energy. Okay, this is the roughly the specification of the wind turbine. If you can see the each part of wind turbine is the fan of the wind turbine. Okay, next slide. Uh, all well known, Malaysia is the one of the potential place for wind turbine energy. Uh, in wind energy, especially at offshore. I said it because wind is blowing from south Chinese Sea will normally occur during the monsoon season in November to February, especially East Coast state. If you can see from the right side, if the speed of the wind, you can see the measurement, the range of the speed of wind. We divide through the seven class, and the left side is we state the example potential place and example the unpotential place. If you can see, we compare the speed of the wine from January to December. You can say that Perhentian Islands is uh, higher, the higher speed of the wine compared to the Mengkama Telipuk. So we can see that a potential place like Perhentian Island is very suitable to develop a wine turbine at the place. Okay, next slide, please. Okay, the aim of Malaysia Wine Turbine to increase national capability for innovation in green technology and development, to ensure sustainable development and conserve the environment for next generation, to inform people about the importance of green technology and its widespread use. Okay, Malaysia is one of the most developed Asian country. So, according to the estimation of International Energy Agency, they target 53% global energy will be consumption in terms of harvesting energy. So, Malaysia is one of the most developed countries also involved in the expand the harvesting energy. One of the harvesting energy is turbine. So next slide. Wind turbine project and collaboration in Malaysia. We all know that Malaysia or previous government of Malaysia already have the initiative or an ETC or project. Firstly, we can see 150 kilowatt of turbine was developed at Pulau Terumbu, Sabah at 1995. And then the second is 100 kilowatt turbine hybrids with 100 kilowatt solar PV and 100 kilo DC at Pertian Island. And third is 3 kilowatt turbine at Setu Terengganu. Like I said before, the East Coast state like Terengganu has a very have potential place, especially offshore. And we can say conduct by University Malaysia Pahang to finding the application wind turbine supply electricity has been expect to sharing farm industry in the high operation cost. Next. In 2019, TMB has collaborated with Argentina Giant Utility Farm, we call it IPSA, to discover wind energy a potential place. IPSA has estimate Malaysia can achieve to generate power between 500 to 2000 megawatt of power source from wind energy. In 2012, Sustainable Energy Development Authority, or we call it SEDA, has requested to propose RFD to develop wind mapping in Malaysia to find a potential place, which is especially at East Coast states. Because at East Coast state have high speed of wind. Last but not least, the latest is in 2019, our former Prime Minister Tun Dr. Mahathir says that government has proposed to construct wind turbine in ocean in east coast of Malaysia. So the conclusion, I will pass to my friend.
So my name is Naufal Awad bin Nordin Asimi. We hear a long story from my friend. So my part is the conclusion. Many previous wind energy studies in Malaysia are grossly inaccurate and are not sufficiently comprehensive. So as we know, Malaysia is a country that we said have a lot of a beach, of a shore. So we can put a wind turbine at the near to the beach, so the wind is flow properly at the beach. And then, as we know also, we also can get a more renewable energy, not from wind but from other things like palm plants. We can use the biomass energy and a lot of energy. Today, technology is quite high, so we can create innovation from that. So, review on global wind energy development found successful installation of wind power capacity depends very much on robust regulatory support and strong political will, something that Malaysia is still lacking and uncertain. So, as we know, you can create a more thing like we can achieve more electricity, not from wind energy, but from another renewable energy. I pass to my friend Azharan Muhammad to close this presentation.
Okay. For my closing speech, many countries are clamoring for new ways to generate energy. We know that our economy is so dependent to fossil fuel, for petroleum, for coal. Sometimes it is good when to produce petroleum, but when the price will go down, it will cause very bad to our economy, especially if we depended for fossil fuel like petroleum and coal for energy generation. So I think the government, our society must focus for alternative energy so that our life and our society, our economy, our civilization will not be dependent for fossil fuel. We all know that the source, the fossil fuels are finite, meaning that they will not last forever. So we must find a better way to generate electricity so that our quality of life, our environment, and our health will improve. So that, in our opinion, we think that harvesting energy through wind power is the better choice for Malaysia in the long run. That's all from us. My name is Muhammad Azhar bin Ahmad from Group 4, and my friends.
Now follow up Binadan Azimi.
Muhammad Maradi.
And Muhammad Arif Muklis. Thank you very much.
Okay, thank you. Assalamualaikum.